Hello colleagues, in this discussion we are looking at how we can use the trapezium rule to determine the integral of 1 out of 1 plus x squared with respect to x within the intervals x is equal to 1 up to x is equal to 4. So let's look at this, and we are having this being evaluated with 7 ordinates. Then we are to correct our answer to 2 decimal places. So let's look at the solution. So what is our h? H is the width of each sub interval, okay? And this is the same as b minus a out of n. But b is 4, okay, and a is 1. But what is n? So since we are talking about 7 ordinates, so 7 ordinates, we are going to be saying that our n, which is the sub-interval is going to be 7 minus 1, and that is going to be 6. So we are going to find that our h is going to be 4 minus 1 divided by 6. This is 3 out of 6, and that is 0.5. So that is step number 1 that you must understand. If you're given n as ordinates, then the sub-intervals is going to be n minus 1. Okay? In other words, it's going to be the number of ordinates minus 1, which gives you, if there are 7, here it is going to give you 6 sub-intervals. So if you have 6 sub-intervals, then you are able to get your h as b minus a out of n, whereby n is the number of sub-intervals, okay, in this case. So what is, we are going to have our x, and we have our f of x, which is 1 out of 1 plus x squared. So since the first x value starts at 1, we are going to be moving at a step size of 0.5. So from 1 to 1.5, so this is going to be 1.0, so 1.5 to 2.0, 2.5, 3.0, 3.5, and 4.0. So we start with substituting our values here for f of x. So for f of x, if I substitute there 1, I'm going to be having 0.500. What is this? So if I substitute in 4, I'm going to be having, is going to be 4 squared plus 1. Then I take 1 out of that answer, and this is going to be 0.0, is going to be 0.059. So what about these other values? So if I get 1 plus 1.5 squared, then I take 1 over that answer. So I'm going to run through that. So this is going to be 0.308, and this is going to be 0.200. The next one is going to be 0.138. The next one is going to be 0.100, and the 3.5 corresponds to f of x of 0.075. So from that matter, from that, I'm going to get integral from 1 to 4 of 1 out of 1 plus x squared with respect to x approximately equal to h out of 2 into, we said this is f of x naught plus f of xn, okay, plus twice sum of f of xi from I is equal to 1 up to n minus 1, and this is going to be h, which is 0.5 divided by 2 into f of x naught is this 0.5 plus 0.059, then plus 2 into the sum of this. So sum of that is going to be 0.308 plus 0.200 plus 0.138 plus 0.1 plus 0.075. So what I have here is 0.821. So times 2, okay, this is going to be 0.25 into, this is 0.559 plus 1.642. So plus 0.559. So I multiply this by 0.25. So finally, this is going to be 0.55025, okay? And this is going to be 0.55 square units if I'm talking about area, okay? But if it is just the integral, it will be 0.55. This is 2 decimal places, which indicates the degree of accuracy. So this is integral of 1 to 4 for 1 plus x squared with respect to